Hello everyone, my name is Paymon Kaur. So today I'm going to talk about the complete option pricing with reinforcement learning from A to Z in Python. So this is about actually how you can price the American option with using your reinforcement learning. So a little bit introduction is that American option are a type of financial derivative that give the holder right, but not the obligation to buy or sell the underlying asset at a specific price on or before a certain date. So American option is type of the contract that give a holder right, but not obligation to buy or sell the underlying asset. So we have two main option. The one is that call option that gives a holder the right to buy the underlying asset at the strike price, and we have a put option which give a holder a right to sell the underlying asset at the strike price. So I think this is our just definition, and but in general I can say two things is that if you are buying the call option, you are betting on that the price of the asset will go up. If you're doing put option, they are betting that the price will go down of the strike price. One example will be very useful. So here is an example of American put option. So let's say you have one contract, which is American put option. Your strike price is $100. Your underlying asset is now $95, and it expires 3 days from now. So, but buying this contract, you should pay some initial premium. So here is a $5 as the initial that you should pay that one, no matter how much your profit will be in continue. So let's say that the price of the underlying asset over the next 3 days is this one. So at day zero, it was 95. At day one, it's become 92, then 88, then 85. So this is how the price evolves. So now it's just an example. We don't know how the future look like. But if this future look like happens, let's imagine we are in day one. So asset price is 92, as you can see here. This is 92. Uh, Exercise value that you can exercise is that you can get the $8 because 100 was, as explained here, was a strike price. So strike price is 100 minus you get the $8 here. Now, if the exercise, you can sell the asset at the strike price because, as I said, you have a right to sell the asset in the American put option at the strike price, and you can buy back at the market price, and your profit will be 8 minus 5 equal to 3. Now, the premium is that this is the money that you gave at the beginning. So this is one example. Um, for example, for the two, if you do it, actually you can make it more profit because 100 minus 88 becomes 12, 12 minus 5 becomes $7. So it's so in American put option, it's just the more the price goes down, you can buy back at the lower price, and you can sell the asset at the strike price because that's your right. Essentially, if you think about American option, is a sequential decision making because at time T1, you need to make a decision whether you are going to continue or sell. Because in American option, at each time step, you can make a decision whether to sell or continue. You can exercise here, or you can wait for the next day, or it reaches the final stage. So I think this is a little bit useful plot because here is that you can think about the profit and how it will look like. So this is an example of the call option, and let's say that this you have a contract with a strike price of $10 and premium dollar of the one premium of the $1. If the underlying asset becomes $20, this is your profit become $9 as a buyer. Because what's happened is that you can buy back the so what you can do is that because this is a call option, you can buy at the price of the 10, and then you can sell at the price of 20, and 10 minus 1 becomes 9. So this will be your profit. In the put option, if you look at if you're the buyer, your profit goes up when the price of underlying asset goes down. So this is a little bit nice visualization that you see it. The big difference is that we have in the European options. In European option, it can only be exercised at maturity, but the American option can be exercised at any point prior to the expiration. So that means that that makes the problem a little complex, because in the American option you just need to exercise before the expiry. You have a right to exercise before the expiration date, but in European option you don't have this one. This added optionality complicates the valuation problem, as the holder must consider optimal early exercise strategy to maximize their return. So here's a little bit the issue is that if you have a right to exercise before the expiry date, so then the question is that what's the best time to exercise? So if you think about the optimal exercise of American option, it's the three things. The first is that you need the function approximation. You can build the function that tells you that in the function will tell you when to stop. So you need to have some idea that at let's say time 0 to the time n, which is the expiration date, at every time step you can give it to the function. You have built the approximated function, and the function says that should you stop or not. And if you can optimally provide a stopping time, then you can evaluate and get the fair value of American option. So that's that premium fee, because premium the value of the option is that with all the right you have before exercising it, how much you should pay as a premium fee to this option. So function approximation, when to stop and exercise, and that gets a valuation. So here is we use a reinforcement learning, which is the strategy is that we have the price data for training, and actually this can be historical data as well. But in this example, I'm building the more I'm building it from the well-known price model with the geometric Brownian motion, because then I want to compare it with some kind of the exact solution, because for some price like a geometric or Brownian motion you can find the exact price. And then here we're doing some feature function, because I need to define some feature function, and then I can feed it to the reinforcement learning algorithm. And the job of reinforcement learning is that this feature function is parameterized with W, and I need to find this W. What's the weight of this approximation function? If I can get to that one from price model, I can generate some testing data, and then I can get the option price. So in reinforcement learning is that we can get some historical data, and also we need to define the function, which is that approximated function, which has some feature function. And with training you can get the weight of the policy. The here weight is that the policy is how we should make a decision, and then with this policy you can apply to the test data, we can get the option price. So now I can go a little bit codings and how to do the codings, and the code is available for you. So here the first thing is that I need to generate data, which is price data, and I'm using the geometrical Brownian motion data. And this is the codes of it, and as you can see is that there's two loops. This is a number of simulation. Number of simulation is that how many simulation of the price I will have, but also you need number of interval, because for example, if you look at here, so the expiry time here is the 1 year, number of interval is a 50, number of simulation values, I have a 10,000 simulation value, spot price is 36, strike value is 40, this is the interest rate, and this is the volatility rate. And then if you run this one, which is generating the data, so we need to bring this data in the reinforcement learning format. So actually what we did is that here is that in NumPy format. I mean, in the results you are getting is that in the kind of the list, that inside each list is that one. So what's here happening is that the result is a list, and the inside list is you have a tuple. The tuple is that you have a time step now, the current price, and next price. So because in reinforcement learning you need to have this, they call it TS0 S1, and this becomes next time step, this becomes your S1, and this becomes your S2. So as you can see that this is now is that your data that you generated, and I'm just looking at the first 3 data points. But the data for reinforcement learning training was generated by the geometrical Brownian motion that as we generated here. Now we need, as I said, we need some feature function for the Q values, and the feature function here is that 3 of them is a time dependent. So at each time step in the reinforcement learning step, I normalize it by the expiry date, and then I define the 3 feature function, and also I define the 3 feature function for the price, because I normalize the price with the strike price. Your feature function here becomes the 6. So you have a 6 feature function. Your function has a 6 of this theta values. That means that you need to find the 6 weight. What are the weights that what's the W values that if you find that for this 6 value, then it will give the optimum exercise strategy. Because essentially what's going on here is that this W that we want to find its optimum value multiplied by this feature function, that defines the predictive continuation values. And you want to see that if this continuation value is more than GS, which is your exercise value, or not. So now we can build the feature function, and now we need to get our W value. What's optimum V values, optimal weights. So here's the one equation that we are going to minimize it, and we can write it as a matrix. A multiplied by W star, and we can get the W star from inverting the matrix, which is kind of I mean, you can write this in this initial function as A and B, and this become A and B, and with every atomic experience, with every SI, S prime that come, you're updating your weights. So then I can run this code, and if someone asks what's the output of this code, what it gives is that it gives you the W star. If you want a little bit more interested, I wrote this paper, so you can look at this paper. That what's the rationale behind this equation. So I'll explain more here. So now. For example, let's do the training. So this make some time that you can get some kind of the weights of this model, and then I can just stop it. If I can run this one now, what I'm doing is that I want to generate some scoring data from the same geometrical Brownian motion, right, with the same volatility, and then I want to generate some price test. So this is for example, this is a first path. This is how the price will look like. This is a second path, for example, and I want to evaluate when I should stop in this the American option. So that's why that defining the option price is that I just need to take an average of all of the option prices in all the paths. And the question is that how you stop in the process is that we are getting the weight, and the weight are the weights comes from here, the weight that we trained here. For example, this goes here. So I'm not running it because it takes 1 or 2 minutes, but I think you can run it. So now, if we can run this one, and then I can just need to run this one. if you can see that how much this option price will look like. So this big option price becomes $4.42, the price of this option. So this makes sense because you can compare it with some other methods. If you use some kind of the least square Monte Carlo method, you will get a very similar and very accurate to this value. But the method we are used here is a more reinforcement learning approach. Now, another thing I did that I'm not going to show, but you can do, is that you just sometimes you try this method to get the different weights. I mean, you repeat the training for 10 times, and then what you get is that, for example, you run this option pricing for 10 times, and then you take an average of it. So it can give an average, which may be a little bit help you with the stability of your method. So that's another method. But here is this is an option price that you get. So now, if you want to a little bit work out and things out, that is, for example, you can change your interest rate, or you can change your volatility rate, and then you see how the option price will change. So I will share this code as well, and I hope that you will like it. And thank you for listening to me.